Good evening, dear students. Yes, so we are discussing the topic D and F block elements, right? So some more extra questions let us do on this chapter. Okay, so we have already covered mm, two classes on this particular chapter. Okay, so let us solve some more. So it will be good practice for you. Yes. Okay. So shall we start? Okay. So this is the first question. Which of the following ions has electronic configuration? Okay, so there is one electronic configuration of one element given. So you have to tell which of the following ions has that electronic configuration of argon 3d6. Yes, argon 3d6. So can you tell? So options are A, nickel plus 3, B, Mn plus 3, C, Fe plus 3, and D, cobalt plus 3. Okay, so the atomic numbers of Mn, iron, cobalt, and nickel is given. And so you can use this data and you can tell. Nickel, argon, 3d8, 4s2. Nickel plus 3 means it will be 3d7. So this is option is wrong. Then Mn 25. So it will be argon 3d5 4s2. Mn plus 3 means it will be 3d4. Right. So this is also wrong option. Then Fe plus 3, argon 3d6 4s2. What it will be? It will be Fe plus 3 means it will be 3d5. So this is also wrong. Let's see for cobalt. Cobalt is 27, argon 3d7, 4s2, cobalt plus 3. It will be 3d6. So which is the correct answer? Option number D. Right. So option number D is the correct answer. Everybody got the same? Option number D. So which of the following ions has the electronic configuration they have asked? That is argon 3d6. So by using these data, okay, we have solved. Is it clear? Shall we go for the next one? Okay. Among the following series of transition metal ions, the one where all metal ions have 3d2 electronic configuration is. So among the following, okay, 4 options are there. You have to tell in which particular option you have 3d2 configuration. So atomic numbers are given of titanium, vanadium, chromium, and manganese. Solve this. Try to solve. I want the answer from you all. It's very simple questions these are. Okay, so already we have solved questions on like this. Okay, just these are some practice questions. How we are going to solve this? Yes, try to answer. Already we have solved. Titanium 22. Okay, so it will be what? Argon 3d2 4s2. Then titanium plus 2 means it will be 3d2. Okay. So similarly do for others. Argon 3d2. Next is what? Vanadium plus 2. Vanadium is what? 23. So it will be argon 3d3 4s2. So vanadium plus 2 is what? Argon 3d3. Okay. Then is your chromium Cr plus 3. Chromium is what? 24. So it will be argon 3d4 4s2. So argon 3d3. So this is also wrong. So your first one is option is wrong. Second option again vanadium plus 4 Mn plus 7. So C, which is the answer you are getting. Sri Varuni has got it as D. Okay. So let us see D. Titanium plus 2. It is 3d2. Correct. Then vanadium plus 3 is vanadium is what? 23. So argon 3d3 4s2. So vanadium plus 2 will be plus 3 will be 3d2. Okay. Next is chromium plus 4. Argon 18 3d4 4s2. So it will be 3d2 again. Okay. So yes, then is Mn plus 5. Mn plus 5 is 3d5 4s2. So it will be again 3d2. Okay. So yes, so option number D is the correct answer. Everybody got the same? Yes, Lubna has also got it as option number D. Very good. Okay. Similarly, so very simple questions. So, okay. Let us go for the next one. Which of the following configuration is correct for iron? What is the correct configuration for iron? Iron is 26. So start filling the electronic configuration. Electronic configuration 26. 1s2, 2s2, 2p6, 3s2, then 3p6, then 3d, 6, 12, 13, 14, 15, 16, 17, 18, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, so it is 3d6, 4s2. So which is the correct answer here? Option number D. Okay, so option number D is the correct answer. Yes, Lubna has answered it right. Sure, option number D. Okay, so for iron, iron is 26. When we fill up the electrons, so this is the correct configuration. Okay. Next question, which of the following has more unpaired d electrons? Yes, C. Unpaired electrons means no pairing will take place. Okay, so which of the following will have the maximum number of unpaired electrons? Sri Varuni has answered it as B. Nickel plus 3, Fe plus 2, zinc plus or copper plus. If I write for Fe, it will be argon 18, 3d6 and 4s2. So Fe plus 2 will be 3d6. So if I fill up the electrons, 1, 2, 3, 4, 5 and 6. So maximum number of electrons are 4 unpaired electrons. Okay, so option number, yes, B is the correct answer. Yes, Lubna and Shivaruni have answered it correct. Very good. Okay, so let us go for the next one. The electronic configuration of transition elements is exhibited by. So what is the electronic configuration of transition elements? Lubna has answered it as C. What about others? What is the general electronic configuration? Okay, Sri Varuni has also answered it correct. Okay, so yes, option number C is the correct. So it is NS2, N minus 1, D 1 to 10. Okay, so this is the correct electronic configuration of transition elements. Okay, so yes, option number C is the, so remember the general electronic configurations. Okay, very important. It can be asked. So there will be confusion in the options. So please go through the options properly and you have to answer it. Okay, let us go for the next one. Identify, okay, we'll see 16th question. The catalytic activity of transition metals and their compounds is ascribed mainly to the catalytic activity of transition metals and their compounds is ascribed mainly to their magnetic behavior, their unfilled d orbitals, their ability to adapt a variable oxidation state, and their chemical reactivity. The catalytic activity, okay, of the transition metals, it is mainly because of what? What is the reason for that? Catalytic activity is shown by the transition metals because they can show variable oxidation state. Okay, so the different type of oxidation state, variable oxidation state means it can, now iron can exhibit in +2 and +3. Okay, nickel +2, cobalt +3. So the answer is due to the variable oxidation state. So transition metals, the catalytic activity, it is due to the property of showing variable oxidation state. So option number C is the correct answer. Okay, so remember this, don't forget. So catalytic activity plays a major role. Okay, fine. Let us go for the next one. So very simple questions, right? Yes. Which of the following ions will exhibit color in aqueous solution? Which of the following ions will exhibit colors in aqueous solution? A, La+3, lanthanum, titanium +3, lutetium +3, and scandium +3. Their atomic numbers are given, so you have to tell which are the for the transition metals to show color. What is the criteria? What is the criteria to show the color? It should have at least one unpaired electron, right? So you have to follow that particular rule here. Okay, yes, Sri Varuni has answered. So for the transition metal to exhibit color, the criteria is that at least one unpaired electron should be present. So out of these 4 options, okay, so whenever the ions, if they have unpaired electron, they will exhibit color. Now when we see titanium +3, okay, if we see titanium +3, write the electronic configuration for titanium and just see. Titanium is what? Titanium is 22. So argon 18, 3d2 and 4s2. So titanium +3 is argon 18 and 3d1. So your option number B, okay, that is titanium. So your when you see the electronic configuration, at least one unpaired electron is there. So because of that, its solution will be colored. And others, if you write the electronic configuration for the other options, you can see there are no unpaired electrons or they are empty. Okay, there is no empty, or either if it is D0 or D10, means what? Either it should be empty or completely filled. Then it will not show any color. It will be colorless. So whenever you want, if any ions will exhibit color, it is due to at least one unpaired electron should be present. Okay, so this is the important criteria that you have to remember. Yes. Let us go for the next one. Which of the following pairs has the same size? Which of the following pairs will have the same size? A, Fe plus 2, Ni plus 2. B, zirconium plus 4 and titanium plus 4. Zirconium plus 4 and hafnium plus 4. Then D, zinc plus 2 and hafnium plus 4. Yes, which will have the same size. And what is the reason why they will have the same size here? Yeah. And yes, somebody was answering. Which of the following pairs will have the same size and which is the answer? And what is the reason why they will have same size? Which pair? Shivaruni has answered it as D. The answer is C. Okay. Hafnium plus 4 and zirconium plus 4. So they belong to 4B. Okay. It belongs to transition elements 4B. Here, here hafnium. Okay. Hafnium plus 4 will have same size. It will have same size as zirconium plus 4 because due to the addition of what? 14th lanthanide elements. So before your zirconium, there is an addition of what? There is an addition of 14 lanthanide series. Okay. So because of that, there will be intervening of 4f orbitals. Okay. There is a 4f subshell. So because of that, what will happen? The electrons, they are added into the 4f subshell. Okay. Because of that, there is a poor shield. There is a poor shield of the outer electrons, and what will happen? There will be contraction in size. So because of that, hafnium and zirconium will almost have same size. Okay, because there is before zirconium there is a addition of 14 lanthanide series. So there is a intervening of 4f orbitals. Okay, so 4f subshell. So because of that, what will happen? Due to poor shielding, the electrons, okay, the contraction, there will be contraction of size. So remember this. Okay, very important. In theory also the question is asked. Why hafnium and zirconium is having almost same size? Okay, if you have studied this, so recall this. Okay, very important. It is asked in type of new reason question. Okay, fine. Yes. It is due to lanthanide contraction. Yes, that only the intervening of 4f orbitals. In which of the following pairs are both the ions colored in aqueous solution? In which of the following pairs are both the ions colored in aqueous solution? Yes, for again you have to see in which of the ions there is unpaired electrons. Yes. Which is the ions which will have unpaired electrons? Shivaruni has answered it as B. Nickel 28, that is argon 18, 3d8 and 4s2, and titanium plus 3, that is titanium is 22, so it is argon 3d2 and 4s2. So nickel in plus 2 state is 3d8 and titanium in plus 3 is 3d1. So if I write the 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8. So here there are 2 unpaired electrons. Here there is 1 unpaired electron. Yes. So option number B. Okay. Option number B is the correct answer. So if you write the other, okay, there will be what? There the at least one of the this is colorless. Okay, so You have to see, analyze all the options. So option number B. Option number B is the correct answer. Fine. Both the ions they have asked, not only one ion, both the ions. So we have to see all the ions. Okay, fine. Let us go for the next one. 4 successive members of the first row transition elements are listed below with their atomic numbers. Which one of them is expected to have the highest third ionization enthalpy? So what is ionization enthalpy? Ionization enthalpy means what, students? It is the minimum amount of energy which is required to remove an electron from an isolated gaseous atom. Okay, suppose we have sodium. When we write the electronic configuration, it is 1s2, 2s2, 2p6 and 3s1. So in the center, our nucleus is there, and around that are our electrons. So 2 electrons here, then your next electrons, that is 8, 4, 5, 6, 7 and 8. And in the last shell, you have the 1 electron. So the energy which is required, okay. So what will happen? The nucleus, and there are 2 types of forces acting here, right? So one is the attractive forces, another is the your action is between what? The positively charged nucleus and the electrons, right? And the which are the dispersive forces between the electrons, right? Negative will they will be opposite to each other, and positive will attract each other, right? So now when you want to remove the electron, so the energy which is supplied, okay, to remove this outermost electron, okay, from an isolated gaseous atom, it is nothing but the ionization enthalpy. So the first ionization enthalpy is always less than second and then the third. Okay, now what they have asked, 4 successive members of the first transition elements are listed. So which is that? Vanadium, chromium, manganese and iron. Okay, so which will have the highest, they have asked. Okay, Lubna and Shivaruni has answered it as C. What about others? So if I write vanadium, okay, now all the electronic atomic numbers are given. So try to analyze this. I have told you the meaning of what is ionization enthalpy. Now here vanadium is what? Vanadium, they have asked vanadium 23. Okay, so they have asked which one? First row transition, 4 successive member, which will have the highest third ionization enthalpy. Third means what? Remove first one, after second, and then third. So third means it should be vanadium plus 4, plus 3. Okay, so it will be argon 18 and 3d2, 4s, 3d3, 4s1. Okay, means argon plus 3 is how much now? Vanadium plus 2. Okay, vanadium plus 2. Okay, so it will be 3d3. 3d3. Then chromium plus 2. If I write the electronic configuration, it will be argon 3d4 and 4s0. Then if I write for Mn plus 2 is 25. Okay, so what it is? Argon 18, 3d 3d5 and 4s0, because plus 2 means 0 electrons in the s orbital, right? Last one, iron, Fe, again Fe plus 2, argon 18 and 3d6. Now here 3d3. Okay, so now when we see the ionization enthalpy, okay, so ionization enthalpy in case of your Mn is how many? It is 3d5. Okay, so here the energy is more, because first comes your vanadium. Okay, when we write the First is your vanadium, then comes chromium, manganese, and iron. Okay. Now, in case of your vanadium, there are 5 electrons, right? There are 5 electrons. So, what happens here? The energy is distributed equally. Okay. So, to remove the electron, it is very difficult. So, this is vanadium. Okay. So, first will be your manganese. First will be your manganese because the electrons are what is electrons are equally distributed. Okay, so the energy required to remove this electrons, it is very difficult to break. Okay, so the third ionization enthalpy. Next one is chromium. Okay, next will be your ionization enthalpy values for Mn. Okay, for Mn the value is 3260. The third ionization enthalpy. For chromium, it is 2990. Then is your iron. Okay, then is your iron with 29 with 2833. Okay, so this is the ionization enthalpy. Okay, so when we see the ionization enthalpy, it is nothing but the minimum amount of energy. Okay, minimum amount of energy which is required. Okay, fine. To remove the electron from an iso, the next one. I hope it is clear. Okay. Okay, this we have already seen such questions. Okay, next question. Which one of the following characteristics of the transition metals is associated with their catalytic activity? A. High enthalpy of atomization. B. Paramagnetic behavior. C. Color of hydrated ions. And D. Variable oxidation states. Which of the following is associated with catalytic activity? Just now we have seen this same. Okay, it is due to variable oxidation state. Yes, option number D. It is due to the variable valency. Okay, that is a variable oxidation state. Okay, because of which they form unstable intermediate compounds readily. So, because of the variable oxidation state. Okay. Which of the following shows maximum number of oxidation states? Which of the following shows maximum number of oxidation state? A. Chromium, B. Iron, C. Mn, and D. Vanadium. Which will show the maximum oxidation state? If I give you iron, okay, so if I take iron oxide, Fe2O3, okay, find out the what is that? Your oxidation state of iron. So it will be 2x plus 3 into minus 2 equals to 0. So 2x minus 6. So 2x is equals to, it is 3. So the maximum oxidation state shown by iron is plus 3. Chromium, if I take one chromium compound, let me take K2Cr2O7. Potassium is plus 2 plus 2x plus 7 into minus 2 equals to 0. We know that, right? First year we have studied what are the common oxidation state. Potassium is plus 1. Oxygen, most common oxidation state is minus 2. Now, if I solve this, so it will be 2 plus 2x minus 14 equals to 0. So 2x minus 12 equals to 0. X is equals to 6. So the maximum oxidation stored by chromium is plus 6. This is plus 3. Next is manganese. So should I take one compound of manganese? I'll take KMnO4. Okay. Again, potassium is plus 1. Mn is X. 4 into minus 2 equals to 0. Solve this. Plus X minus 8 equals to 0. So X is equals to 7. Okay. So the maximum oxidation state shown by which of the following is maximum? It is Mn. It is Mn. Okay. It is Mn. So Mn is in which group? It is in the 7th group, and it is showing the maximum number of oxidation state. Is it clear? Is it clear? Yes. Okay. So option number C. Yes. Sri Varuni and Lubna have answered it correct. Very good. Okay. Fine. Let us go for the next one. So very simple questions, right? Which ion is colorless? Which ion is colorless? For the colorless ions to show, it should have either completely filled orbital or D0 system. Now here they have not given you the atomic numbers. So you have to use your data. Okay. Chromium. What is chromium? Chromium is 24. Titanium is how much? Titanium is 22. Scandium is how much? So scandium. So put the data and use your this. Okay. And vanadium. So all these data to use. Palladium is 23. Yes. Just see which is the answer. What you are getting? Okay, Sri Varuni has got radium is +3. So argon 18. Then comes 18, 19, 20, 21. Right. So it will be 3D 1, 4s2. So scandium in +3 state, it will be argon 18. Okay. And 3D0. So yes, option number B, correct. So there are no unpaired electrons in the no unpaired d electrons. Okay, therefore it is colorless in its solution. So yes, option number B is the correct answer. Very good. Okay. Bell metal is an alloy of. What is alloy, students? Anybody knows what is alloy? What is alloy, students? Anybody knows? Very important, alloy. Mixture of two or more metal. Very good. Okay, so bell metal. Okay, so bell metal is what? Bell metal, it consists of copper and tin. Okay, copper and tin. So bell metals, it is where it is used for making the bells. Okay, to making the bells. Then for utensils, we use the bell metal. So it consists of 80% of copper. Okay, 80% of copper and 20% of tin. Remember this. So option number B. Okay, bell metal, where it is used in making the bells. Okay, the bells which we use in temples, in our house, right? So yes, what is a alloy? Alloy is a mixture of metals. Okay, it is a mixture of two or more metals. Very good. Okay, let us go for the next one. So very simple questions. Okay. Okay, in which of the following compound transition metal has zero oxidation state? In which of the following compound transition metal will have zero oxidation state? Where is the transition metal? Check for C and D. Okay, check for C and D. Chromium X plus 5 into -2 equals to 0. X minus 10. X is equals to 10. Okay, so here the oxidation state is 10. Then for Fe. So when we see for Fe and carbonyl, pentacarbonyl, okay, X plus 5 into 0. Carbonyl is 0 equals to 0. So X will be 0. So yes, option number D. Option number D. Yes, Sri Varuni and Lubna have answered it correct. So option number D is the correct answer. Okay, option number D. So in which of the following compounds will have the zero oxidation state is option number D. Yes. A transition element is there, okay, and that transition element is X, and it has an configuration of argon 3d4 in its, okay, in its +3 state. What is its atomic number? Can anybody tell? So they have asked in a twisted manner, in reverse manner. So one element is given, it is already in its +3 state, that is argon 3d4. So you have to tell what is the atomic number. Means the metal will have 3 electrons more, right? The metal atom will have 3 more electrons. So if it is here, how many it is? Atomic number of the metal will be what? Argon is 18. Okay, 18, 19, 20, 21, 22 plus 20, 18 plus 4 plus 3. 18, 19, 20, 21, 22, 23, 24, 25. So it is C. Okay, understood? Very simple, no? Yes, 25. Very good. Sri Varuni has answered it. So already what they have told, X element in its +3 oxidation state. Argon is how many? Argon means 18, 3d4. So add 18 plus 4, and +3 means add 3 more extra electrons. So it is 25. Okay, so option number, yes, C. Very good. Lubna has also answered it. Very good. Okay. Yes, that is manganese. Yes. Option number C, 25 is of manganese. Very good. The mercury is the only metal which is liquid at 0 degrees Celsius. It is due to its A, high vapor pressure, B, weak metallic bond, C, high ionization energy, and D, B and C. Yes? The mercury is the only metal which is liquid. We know that liquid, it is a liquid metal at 0 degrees Celsius. What is the reason why mercury is liquid in state? Options, there are 4 options: high vapor pressure, weak metallic bond, high ionization energy, and both B and C. So the answer is D. Okay, the option number D means that is both the option B and C is the correct answer. Because of high ionization enthalpy, okay, mercury. So mercury, it makes the electron it is very difficult for the electron in forming metal-metal bonding. Okay, so because of that, it is liquid at 0 degrees Celsius. So because of high ionization energy, there is no formation of, the electrons cannot form metal-metal bond. Okay, so because of that reason, the mercury, it is a metal, but it is in liquid state. Okay, these are the reason, that is due to weak metallic bond, and because the electrons cannot participate in metallic bonding, and due to high ionization energy. Okay, fine. The manganate and permanganate ions, they are tetrahedral due to, so the manganate and permanganate ions, they are tetrahedral due to. Okay, so these are the questions from important compounds. Okay. The pi bonding involves overlap of d orbitals of oxygen with d orbital of manganese. B, the pi bonding involves overlap of p orbitals of oxygen with the d orbitals of manganese. C, there is no pi bonding. D, the pi bonding involves overlap of p orbitals of oxygen with p orbitals of manganese. So if I write the magnet and permanganate ions, okay, if I write the structure, so Mn, okay, Mn, it is the tetrahedral structure is like this, okay, of manganate ion, which is manganate ion is which color? It is green color, okay. And if I write permanganate ion, Mn, so this is purple in color. This is purple in color. This is permanganate, and this is manganate. Okay. So you can see here in manganate and permanganate ions. Okay. Here pi bonding takes place by overlap of p orbitals of oxygen with d orbitals of manganese. Okay. So when we see bonding, the pi bonding orbitals oxygen and d orbitals of manganese. Okay. In Mn is a transition element which involves involvement of d orbitals. Okay. And in oxygen, we have p orbitals. Right. So there is a involvement of what bond? P orbitals of oxygen and d orbitals of manganese. Okay. So option number B is the correct answer. So oxygen is what? Oxygen is 8, 1s2, 2s2 and 2p4. Right. So p orbital sign what? In Mn 25. Okay. So that is 3d 5 4s2. So here d orbitals are involved. So the pi bonding is involving what? Overlap of p orbitals of oxygen and d orbitals of manganese. So this overlap takes place. I hope it is clear. Yes. Okay. Fine. Oxygen does not have d orbitals, Sri Varun. Okay. If you write the electronic you will have what? P orbitals. So there is no involvement of d orbitals in oxygen, because if you write the electronic configuration, it is O8, right? 1s2, 2s2, 2p4. So there is involvement of p orbitals of oxygen and d orbitals of manganese. Okay. I hope this is clear. Okay, so we'll solve some of the oxidation states. Find out the oxidation state of chromium in K2Cr2O7 is. What is the oxidation state of chromium? Potassium is 2 plus 2x plus 7 into minus 2 equals to 0. 2 plus 2x minus 14 equals to 0. 2x minus 12 equals to 0. X is equals to 6. So option number C. Electronic configurations are, the oxidation states are very important. Okay. So it can be asked in redox reaction, first chapter. Okay. Redox reaction as well as in your DNA block. So in your inorganic chemistry. Okay. These type of questions are asked most commonly. Okay. Which of the following statements related to lanthanons is incorrect? Europium shows +2 oxidation state. The basicity decreases as the ionic radius decreases from Pr to lutetium. All the lanthanons are much more reactive than aluminium. Cerium +4 solutions are widely used as oxidizing agent in volumetric analysis. Whenever we see the lanthanide series, the first few members of lanthanide series, they are very reactive. Okay, they are quite reactive, almost like the calcium. But as there is increase in atomic number, what will happen? They behave as that like aluminium. So option number C. Okay. first the few members, how they are, so this is incorrect. Okay. So all the lanthanants are much more reactive than aluminum. No. Okay. First few electrons, first few elements, they are highly reactive. Okay. As there is increase in atomic number, what will happen? They behave similar to that of aluminum, not more reactive than aluminum. They behave similar to that of aluminum. Okay. So option number C is the incorrect statement. So these are some of the, this is, we have already seen this. Okay. Yes. Reason for lanthanide contraction is A, negligible screening effect of F orbitals, B, increasing nuclear charge, C, decreasing nuclear charge, and D, decreasing screening effect. Yes. What is the lanthanide contraction? What is the reason? It is due to poor shielding of 4f orbital. So that is the negligible screening of 4f orbital. Okay. So what will happen? The nucleus, what it will do? It will force of attraction between the electrons. Okay. So what will happen? It will have a strong attraction force between the nucleus and the outermost electron. So because of that, what will happen? The size will go on decreases as there is increase in atomic number. So option number A is the correct answer. Okay. So what is the reason? It is due to negligible screening effect of f orbital. Okay. I hope this is clear. Very simple questions they are. Okay, which of the following oxidation state is most common among the lanthanoids? Which is the most common oxidation state in lanthanoids? It is +3. Okay, it is +3. Remember that. Don't forget. Yes, +3. Okay, so +3 is the +2 and +4 is also exhibited, but +3 is the most common. Okay, they have asked most common. So it is +3. Okay, fine. So fine. So these are some of the important questions I thought of solving this today. Okay, so these are some of the practice questions which we have solved today. I hope you have understood. Okay. So by this, we have completed the chapter D and F block elements. Okay. I hope all the questions particular chapter. Okay. So in the next class, I'm going to start with a new topic. Okay. I hope all your doubts are clear. Any doubts from this particular chapter? Okay. Fine. Okay. Fine. So no doubts. I hope all your doubts are clear. Fine. So by this, I shall end the session here. Okay. We'll meet in the next week with the new topic. Yes. Thank you. Have a good day.